Hey, welcome to Engineers Workshop. Coming to you live on the road again. Seems like I've been doing more service visits since the lockdown than before, but you do what you got to do. So, over the past 20 to 30 years, I've accumulated quite a number of pretty cool tools. Um, my wife has a different word for it, but I tell you, I don't think I'm a hoarder. And to me, a hoarder, I've envisioned stacks of useless stuff, magazines and newspapers, no intrinsic value or use to anybody, just kind of piling up around a person. I prefer to view what I do as a carefully considered selection of things that will be useful to me, or if not, they're just too cool to pass up, and I will make use for them at some point in the future. And I put a few things to use putting the shop together. But used to work for Reynolds Metals Company can division a number of years ago, and they were sold out to Alcoa in actually two stages. And so a number of things were, well, a whole bunch of things were getting thrown away from the engineering group, and I managed to get save a few of those things from the dumpster. And so, first episode of Cool Tools I am going to bring to you is about one of those items that I rescued from Reynolds Metals Company. So, Cool Tools episode number one. One of the neatest things I have, and this is a test instrument. It's a handheld digital tachometer made by Shimpo, model DT-105. This thing dates back to probably, I would say, the 1980s. When there's no internet references on the instructions, and they're they're referencing a telex number. Boy, look that one up. I remember when the teletype machines were still in the companies, but this thing has some quite impressive specifications. It will do RPM up to 25,000 and revolutions per second, revolutions per hour. These are all selectable on a dial with discrete switches. And we'll also do yards per minute, yards per second, yards per hour, centimeters per second. What else? Feet per minute, feet per second, feet per hour, inches per minute, inches per second, inches per hour. And all this it does the math inside the machine, but it's a really, really nicely made piece of equipment. It has that real heavy crinkle finish that you used to see on most of your old cameras, and it's a cast aluminum. It's a die-cast aluminum body, heavy enough that if you dropped it on your foot, it would hurt. It's not like some of the stuff that you get today that weighs barely a couple ounces. Believe it or not, I looked on eBay, and these are still available, this model, and they look a little newer. They're about $150, so no big shakes to replace this. And if you want something very rudimentary, the light-based ones, which have a piece of reflective tape, and they just you stick the reflective tape on whatever rotating member you're trying to measure. You can get those for about $15. But this has a shaft with an indexing pin, and then it has all of these components. It has an extension. It has a conical wheel with an indent, and it has two different conical points. Let's call these male, and then a female one. But the one thing that it has, which you don't have on the really El Cheapos, is this wheel right here. And this wheel, which also has a set screw attachment, if you put this wheel on, this wheel, and the set screw is not run in enough, but you can lay this wheel against the face of a shiv or a belt, and this is what reads in feet per minute. Running this surface against your rotating item will give you feet per minute. So if you're working with conveyors or belting, there is an optimum feet per minute that you want to shoot for. Now, I was kind of neglectful. I had this thing sitting on a shelf for years and years and years. And one day I thought, oh boy, I never took the batteries out of this thing. So the batteries ended up corroding into it. And to access the battery compartment, you have these two screws, and it's been ages since somebody's seen these, but these are called dime slotted screws. And they used to use these on cameras and other instruments because you always had a tool in your pocket that you could use to open them up. Well, nowadays, you know, I have to go and carry cash into the gas station and buy a candy bar or something to get one of these tools. But it's funny because a dime is not the best tool to open these. It actually fits the diameter and the width of a nickel almost exactly. But like I said, they call them dime slotted screws for some reason, even though it's a nickel that opens them up. But basically, let's get this thing apart and we'll show you the inside. And then we'll see if we can clean it up and get it working again. I hope it works because I like this one, and I have one of the little light-based ones as a backup. But I definitely want to get this old boy working. I could just call the company Indimation Company if they're still in business and see if they could help me out. But when you get it open, and you can see this thing has, you know, very nicely die cast components. It has this is like a shock mount for the circuit board, and it's divided into two parts. It's divided into a mechanical section with the shaft, two precision bearings, and a spacer. And you can see the, actually it'd be better if I were to set this the other way. Let's do this. So we have the shaft, two bearings, and a spacer. And then there's this wheel with a bunch of windows cut in it. And here you have infrared emitter and receiver. And that light beam is actually interrupted, and the pulses are counted as this wheel rotates past it. So these are completely separate. The electrical part comes off, and you're left with the mechanical part. Now, I've never counted how many windows there were. Maybe I'll do that. All right, let's count the windows. Okay, I counted the windows. There are 60 windows in here. So if somebody wants to do the math, 25,000 RPM times 60 windows, that's a lot of windows per minute. It's a lot of windows per second also, or a lot of hertz. But what I would like to do is I would like to try to clean up the corrosion that's on this thing, and then get everything back together and see if we can get this thing to power up. Basically, when I put batteries in it and press the button, I got no display. So shame on me for letting this thing get full of battery acid. And you got your discrete switch here. You've got your test button, I believe. Actually, this is the memory, and then the button on the side is what activates it. So yeah, we got some corrosion on the battery terminals and some on the circuit board itself. I don't know what this component is in here. It looks like a resistor. I don't see any evidence of corrosion in between any of the terminals. A lot of times if you get something wet, you'll have what's called dendritic growth between the terminals on a circuit board. If there's a voltage potential there, little crystals of crud grow between them. Don't see any of that. So this basically sat just like this. It was at this funny slant. And then we had these little posts holding down the back end of the circuit board. Can't forget that. I did not bring a wrench with me, but these have, they're brass, and I'm not going to go crazy tightening them. Finger tight should do it. Okay. I don't know if the window on this thing was as yellow as it became through age, or if it was always that way. I just don't remember. But I do know that it worked at one time. And here we have two different length screws. Okay. Moment of truth. These are new batteries. I'll put a link on the website, and I'll send you one of these special tools for 25 cents. Womp, womp, womp. Okay. Oh my gosh, I think we have continuity. Yes. Let's take it out to the shop and let's measure something. The conical points work real well on the shafts of motors because of the centers. $847. $258.8. Now I'm going to check the high speed on the compressor and also the belt speed in feet per minute. Actually getting slightly above synchronous speed, 1804, so that's the VFD. And 552. Once again, we tighten our set screw on the wheel, and we're looking for feet per minute, so that's F. Like 2863 feet per minute. And the closer you run a belt to 5,000 feet per minute, the more power that it can transmit. I'm going to switch back over to revolutions per minute and wait for this to kick down into intermediate speed. $13.25. Looks like about, can't tell if that's 407 or 487. I think it's 407, 408. And there's our idle speed once again. 258.8. The generator is definitely something that you want to check the RPM on so that you are getting your 60 hertz correct, and that is 1800 RPM for this generator. Now, since this crankshaft does not have a conical or like a center, I'm going to try the cup center and just try to get it squared up in the center of that bolt. Let's get her all fired up. And we'll let it run for a bit and stabilize. So that's 1860 to 1870. A bit high, but when it's under load, that's going to come down closer to 1800. So I think I'm going to leave it where it is. You have a convenient hole in the ceiling there, helping me spotlight the numbers on the Tach. Let's really give it a workout. Okay, the grinder says 11,000 RPM, but this says 9516 or 9576, and I believe this. So not 11,000. So once again, that belt speed with the contact wheel is the one thing that the light-based El Cheapos cannot give you. I guess you could calculate it, but it's nice to not have to calculate it, and that's about all I have to check right now. Hope you enjoyed it. We'll be back with another tool next time.